So another construction in geometry, again, traditional constructions use a compass and a straight edge, and you can see that compass there, and a straight edge is not a ruler, it's just a straight edge. And we're modifying traditional compasses here, traditional constructions here, and using a ruler and also a protractor to measure some angles, because we're playing around with angles too. And we're going to use Geogebra to do this. And so, as mentioned in a previous video, the kind of traditional tools for doing constructions would be, say, this set of tools in Geogebra, and we're adding on the angle measure tool, building an angle of a given size, and maybe using a distance or a circle based on a center, and we say, hey, we want the radius to be 1 unit or 2 units, which is a little different than the circle with a center and a point. So let's try a new one. And I don't want that anymore. So I'm using the Geogebra geometry tool. And if you go to get yourself to geogebra.org, you have a whole bunch of options. If you just choose the start graphing tool, that takes you to the graphing calculator. You can get to all these geometry options through there, and you just have the grid in the background to use too. So I can do the same stuff from the graphing calculator. I just like the clean look of the geometry one. So the geometry one is almost the same, they just have a slightly different display method. But again, they're pretty comparable. So what I want to do this time is a slightly different version of the construction where, no, I'm sorry about that, where I'm going to embed embed the pentagon in a circle. So if we go back to my notebook here, instead of going around and starting with a line segment and an angle and working around that way, what I'm going to do instead is start with a circle and a center on that circle. And then if I'm making a pentagon, right, then what I'm going to do is I'm going to split that 360 degrees into 5 chunks. And so each of those 5 chunks should then be, equiangular coming around. And if I do those 5 chunks right, 360 divided by 5 should be 72 degrees. So each of these should be 72 degrees coming around. And if I know where those points are at each 72 degree jump, then if I connect those points, I'm going to end up with my regular pentagon. So it's a slightly different way of coming about it. And again, any math problem, there's always more than one way to do it. So we're going to give this version a shot next. So to do that, I want to start off with some circle, and pretty much any old circle will do. So I'm just going to pick this circle right here. And then what I need to do is from this line segment AB, I need to find where 72 degrees is out here on the circle, and then I'm going to jump around using that. And this is a pretty version of it. I really like this version. So next thing I need to do is actually pick an angle of a given size. So that's this tool. And again, the way that tool works is the second point is where the angle comes from. So I'm going to start at B and then click A, and I'm going to measure. In this case, I'm going to come around again counterclockwise, and I don't want 108, I want 72 this time because I'm doing the central angle is what this one's called. So, okay, so there's my central angle. And again, if I take a 72 and another 72 and another, if I take 5 72-degree angles, that's going to give me a 360-degree rotation, which should take me back to point B here. So I'm going to zoom out a little bit on this. So it's still the same circle, I just zoomed out. You can zoom in and out all day long. And you can use the move tool to oops, I didn't mean to plot a point. Undo, undo, sure, that's fine. You can always use the move tool also to move stuff around. So with the move tool, I can move the whole screen around if I click in the white space, or if I click on a point, that can move that point. So B is part of the circle's radius, so it's enlarging the circle, and A is the center, so that would move the center around, but notice B is stuck. Okay, so sometimes things move in interesting ways once you start building them. So what we need to do is we want to replicate this angle, and there's several ways to do that. instead of repeating the angle tool, I'm going to use a slightly different method here. I'm just going to mark off this distance around the circle. And the traditional way to do that is with a protractor, and this circle with a center is kind of like the protractor tool. So I'm going to start at this point here, and I'm going to make that point there the radius in between them. So I'm going to click there. And I'm going to reverse that too. I'm going to make this the center and that the radius point. Now, when I do that, what happens is I'm replicating this arc here and here, which means that should be a 72-degree angle from A as the vertex, B prime, and then this point over here. So I need to find that point there, and similarly this one over here. So there's a tool for finding intersection points down here. If you don't see this tool, then your tools are still compressed. So I'm going to back off here. So again, this is the initial set of tools in GeoGebra's geometry version. If I hit more, I get a whole bunch. And I believe the intersection tool is still not there. And so I'm going to hit more once again and go back up. And then I should see there's under points is the intersect tool. And there's two ways the intersect tool works. You can just point at the intersection and click, or you can click on the two objects you want to find out where they meet. In this case, that would give me that point right there, and it would replicate a new version of that point. So I'm just going to click on the intersection, which just gives me that single point instead of its pair over there. And I'm just going to repeat this again because I need to get this point over here. So back to, let's see, where is the circle tool? Is it at the top still? There we go. So back with the circle with center. And so basically I'm going to use this as my center and that, oops, nope, that was incorrect. I went the wrong way. Escape in the middle of something undoes it. I wanted this as the center and I lost my tool. This is the center and that is the radius. And I'm going to do the same thing over here. This is the center and that at the radius. And you can see I'm getting an interesting pattern going with the circles here. I want to find that intersection point. And it would have been enough to have just done this circle to find that, but I'm kind of making this pretty also. It's fun to make things pretty sometimes. So intersect, find that point. And we're going to do this one more time because if you zoom out on this a sec, you'll notice that there's a circle coming from each of these other points except that one. So let's put a circle here to match the others, just for fun. Center, and then radius is either that point or that one. And if we have the 72 degrees right as the central angle, then these should be a bunch of 72s going around. And notice I made a lot of cool stuff here. I made this kind of cool flower petal inside. I made this circular flower outside. But if I connect these vertices here, then I'm going to get the regular pentagon that I desired with a whole bunch of other cool stuff. So let's see, polygon tool. So now I'm just going to emphasize the polygon by going around and then getting back to where I started. And if you know the central angle, you can make any regular polygon this way. It might be easier to use that GeoGebra tool that just says, hey, make me a regular polygon, but this is a heck of a lot more fun, and it's way prettier. Check that out. Isn't that beautiful? I can hang that on my fridge. All right, that's it for now. Take care. Do good math. Bye-bye. If I can figure out how to shut this off. Where's my mouse? Oh, no. Did I break my computer? Come on, computer. Oh. Well, now. Oh, there's my mouse. And there it is. And bye-bye for real now.